First, we could just note that from one of your slides that energy efficiency seems to be one of the key technologies for saving our planet, actually. And, the Swedish Energy Commission, which is a parliamentary commission, they had their final report now in January, and they have two major goals in that report that will be transformed into governmental bills. They say that one of these goals is by 2030, Sweden's energy use is to be 50% more efficient than in 2005. The target is expressed in terms of primary energy use in relation to gross domestic product. So the question to you in our panel is energy efficiency this important, and how important is it to you? Should you start off, Matthias?
Well, I would say that it's very important. I mean, this is it's both from a climate perspective very good, but it's also from a competitive perspective very good for us to be energy efficient. If we can lower our cost for primary energy, we can be competitive even longer and produce the products that the market demands at a lower cost and at a lower impact to the environment.
Yeah. Further comments, please, Uwe?
Well, once again, from an energy company's perspective, I think we have, from a historical point of view, sometimes we have set the kind of the border between the industry and the energy utility at the gate, and then we deliver something to them. We deliver to 440 volts or whatever, 230 volts, and then we deliver 6-bar natural gas, and we deliver district heating at 90 degrees and so on. I think that time is more or less has come to an end. I think we are moving more and more away of just supplying energy to industries, and we are moving more into something that we want to be a partner of an industry and also integrate the industries into the energy network in a completely new way. And I think this is also further assisted by the digitalisation, that it's now possible to keep track of more or less everything that happens in an industry. You can track every temperature, everything that happens, not only kind of structured data like temperature, pressures and so on, but also unstructured data, notes in maintenance schedules and so on. So I think by integrating the energy networks with an industry, there is an enormous amount of savings to be done. Like, for example, moving away from just supplying something then to having a kind of a demand management system, demand side management system or demand response systems, and moving more into virtual power plants. If we could kind of reduce the amount of energy an industry uses at a certain time, we could, of course, there will be effects also in our system. So I would like to I think this is an extremely important topic, not only from an industry point of view, but also from a national point of view. But you have to see it more from a holistic point of view. And I think that's something we could do together with the industry.
Thank you. And what is the situation at Stora Enso then?
I think it's extremely important, and that we are also trying to respond to in actions. And when it comes to system optimization, we had, say, 10 years ago, a situation in Sweden where we were struggling with getting volumes of heat volumes to the district heating networks. There are still improvements to be made, but it has been proved that it's possible to shut down boilers in the district heating system and utilize excess heat from the industry, not only pulp and paper. And furthermore, we have also been able to convince some of our internal energy experts in the mills that it is safe to operate with one boiler less running. So basic things like this takes a hell of a lot of time and convincing, but it is a fundamental part of the energy efficiency work to really dare to operate a site with less boiler capacity active, for example. So that's and the more you connect it, I think it's a very interesting study that have been made in the Gävle, Sandviken, Hofors area regarding the district heating system optimization. And depressing for Gävle Energi was that the newest bio combined heat and power plant, Johannes, was the least competitive one in the system. So that would have to be more or less completely shut down, and the industries will be able to supply the needed heat for the municipalities if they were ever connected. But there is one obstacle remaining, and that is the firm belief that every player must be required to, at every time during the winter, live up to the maximum commitment that you make. So the focus on the extremes and the special situations are preventing faster progress.
Thank you. And what about Perstorp then? Where are you when it comes to energy efficiency?
Again, congratulations to Chalmers and this very, very good research on system integration and energy efficiency. And I'm a big fan of your research, Simon, you know that. This should really be a no-brainer to save energy, make yourself more competitive in a global world. And I agree with all the previous speakers here. But having said that, again, in a private industry, there is a competition over money, and energy savings are not always those products having the best possible payback term, since what Simon didn't mention is that it costs quite a lot to get after these megawatts as well. And I think that is a challenge we need to find a way to justify maybe not the best payback project ever in an industry, but which gives you a long-term competitive edge on energy saving, and at the same time contributes to reducing the carbon footprint. Well,
one comment on that.
Well, I can agree to what Lars is saying. Actually, when we put projects up against each other in terms of profitability, our demands for energy saving projects are lower. So the return on investment requirements for energy projects is lower than, let's say, margin increase projects, because the energy saving projects are fundamentally more robust than changes in between margins between different products, for instance. And we have been using this way of thinking for a very long time, and we have over the course of the last 10-15 years had a very good development in terms of our energy efficiency index in our refineries. So they have gone from being in sort of the second quartile into firmly deep into the first quartile, and are now competitive to any refinery in the world. So by adopting a little bit of a lower demand for return on investment, you can get really far.
Simon, could you please show us the slide where you had, housekeeping in the bottom?
Yep, I can.
I think it was the fourth slide or something.
Housekeeping at the bottom. You don't like housekeeping?
I like housekeeping.
It's coming. Maybe it's easier if I do it this way. Housekeeping.
Number 7, perhaps.
this guy, for example.
Yeah. So if you from the industry look at this slide, because to me it kind of summarizes the different kind of measures that you could focus on. Could you just elaborate a little bit on where are you in your thinking? What are your challenges when it comes to different levels of energy efficiency measures? But the first question is perhaps, do you agree on this slide that it's kind of good slide to show what the challenges are in industry and what different kind of measures to perform? Lars, could you perhaps start off?
Well, absolutely. I think it's also a slide over what you control yourself and where you need to interact with others. And the first two ones, I guess, is totally in the own company's control. When you move out into more units, it might involve other legal units, other companies, or other players, and then it gets more complicated. And of course, process integration even more so. And I think we have seen the Stenungsund example on the slide here, which involves 5 companies. And I think that is one of the complicating factors, that you need to agree with many various companies on various values on very different energy sort of quality levels. How much is a ton of natural gas worth compared to a 60 degrees C water stream somewhere? Where is Perstorp on this line? I think we have dotted points in all boxes basically here, but of course more what we can control ourselves in the lower part.
But perhaps the greatest achievements can be done the more up you go, or
we are a significant part of that 122 megawatt saving potential that Simon showed, that we have difficulty getting after. So yes, indeed.
Yeah. Matthias?
I think that what Ove said is something that is lacking in this picture, is that system-wide optimization, so energy system optimization. It can be how we use electricity, how we interact between industries with electrical grid as sort of the connector. So that's, maybe that is alternative processes, but that's, or you can argue that is missing.
I think it was in there.
But you can also argue that taking Lysekil refinery as an example, where we have a potential of roughly 0.8 terawatt hours of district or waste heat that is not utilized. So those system way of thinking is where a lot of potential still lies, where we can save burning biomass in the 3 city area of Vänersborg, Trollhättan and Uddevalla, and delivering waste heat from the refineries, we think is very underutilized today.
I could comment on that, but I think most of what you said is in that grey box. But what isn't, and I fully agree with Ove, is the demand side management and working together with utility companies to identify options to shut down or to turn down industry when it makes sense, and to try and develop technologies to make that less painful than it needs to be with not non-flexible equipment. So, and that should be there. I would agree there.
So the government says perhaps that we should reduce our energy use by 50% to 2030, which is in like 13 years compared to 2005. So we have already come a bit on that road. If you are looking at this slide and consider perhaps what kind of policy measures from the government should be in place to do this, what do you think? What is effective? What do you react on? What is important to you, and what to avoid as well?
I think we have to go deeper down in the system than only the government, even though they make the national policies. But there are many times severe impact from regional politicians as well, or local ones. So let's keep the whole decision power on the public side connected to this, because there is still counterproductive policies in place. If you are incentivized to produce renewable electricity, but you are not required to meet a certain efficiency level, and you are fully allowed to waste 80% of the energy value in terms of just maximizing renewable electricity output in bioelectricity. So things like that are quite fundamental. Companies, utility companies, industry, everyone utilizes the incremental margin that is achievable. So it needs to be a consistent total energy efficiency boundary set also, or then incentives and policies that are guiding in a certain technology direction should be clearly time limited for a technology introduction period, and then it should stand on its own.
It seems like Uwe also want to say something on policy and energy efficiency.
Well, I'm just thinking about it. We always talk about energy efficiency, and when it comes to electricity, it's becoming somewhat irrelevant now, because most of what you're paying for electricity is actually for being connected to the grid. So as having a certain power input, the electricity price is it's not very low, of course, but it's still. And so I think sometimes it might be more relevant also talking about power efficiency, not only energy efficiency, because I think this will be where you really can kind of have a financial benefit in the future, reducing your power input, not reducing energy. Energy will be quite cheap, but power input will be quite expensive. So I don't know if that changes your kind of overall setup, but I think that's an important distinction.
It is, and the comment, well, we're moving into the electrification, and that's part of it, is the interaction with the market, and the market is changing very rapidly and very fundamentally in price structures and intermittency and the price signals generated by that, and the role of industry in being more flexible. So we have ongoing projects there when those are very much the questions we'll try and answer. Together with our colleagues at Energy Technology, we're also developing the models about how the power market will look like maybe in the future. So lots of interaction there as well.
Just if I may say a final word about, maybe it's completely different, but a very important energy efficiency measure is maintenance. And taking into account the processes get more and more digital, you get more and more information out from them. You can also do quite a lot with that information to do a kind of condition-based maintenance and so on, just to improve energy efficiency. So it's not only about recovering and duct tape and all that, but it's also about controlling your processes and doing. I don't know if there is any activities on that, but we have seen that that's very efficient. It's very important for you.
Simon showed kind of broad.
I was sleeping. Sorry.
No problem. Simon showed kind of broad picture on what we are doing when it comes to energy-intensive industry. We have to say that it's not other industries than energy-intensive industries. But are there things here on the slides and from Simon's presentations that you perhaps lack on Chalmers that you want us to work more on? I want to overpoint that. The systems integration, I guess. Yeah.
This predictive maintenance you're pointing out? Yeah, good. Thought so.
Please.
Mike's off.
Lars, or any comment on that?
Well, first on the policy side, I have two comments. One, I would like to fill in what Mattias said, that I think we as a society, we are wasting a lot of energy from industrial processes by not wishing it to heat our cities. We rather prioritize bio-based combined heat and power plants and let waste heat from like Prims and many other places go out into the recipient. That could be changed by a policy or legislation, which I think we should do. On the other side, of course, industry needs cheap energy, or at least fairly priced energy. And as we discussed earlier, if there would be a carbon price on all fossil fuels, also energy would be more expensive on a global competitive way. And that would also give this kind of projects a higher payback and quicker implementation, I'm sure. On what we are missing from Chalmers, I don't think I miss a lot, but I think maybe you should market it more because you do a lot of good work that is not generally known.
Yeah. Mikael, please.
We are putting a lot of hope into the area of digitalization of our processes, process operations, including the predictive maintenance, but also taking the next steps after that to go to autonomous systems. And that is to avoid manually induced energy wasting. Because that is a typical revolving housekeeping problem, that we need to be on a certain amount of manually imposed valve settings, etc., every damn day in certain process departments. And this is the behavioral pattern that develops and redevelops when you take it away. So, like in the transport sector with autonomous cars to reduce the traffic jams, etc., we think that there is a potential in utilizing the control systems on an even more efficient level.
Because machines are smarter than we are. More predictable. I will open up the floor for questions in relation to energy efficiency. First, we got Philip and then Henrik. Sorry, I don't know all your names, but please, if you have any questions, Philip and then Henrik.
Yeah, I'm thinking that in the related to Ove's comments there about the difference between energy and power, and that in any sort of future scenarios, we will obviously have a lot more of variable electricity generation, like wind power and solar, of course, and that, of course, creates the possibility to increase the value of the renewables by shifting electricity to another sector, such as electro fuels or something. On the other hand, today we have, which is fortunate, we have very low electricity prices, but we may lack financial resources to invest. So what would you think, would it be the industry that drives this transformation, or will it be the recently proposed certificate system? I think there is an additional 18 terawatt hour proposed. Or will it be maybe the EU ETS, which we may have agreed in the previous session is rather weak, but how do you see that? Well, how will it come about, this sort of future electricity system where we can integrate much more of the variable renewable with demand side, including the industry?
All right, what is your role when it comes to this new electricity situation?
I can say something about, in terms of liquefied fuels, we see that hydrogen will play a future very big role, and producing hydrogen from electricity is interesting and can sort of help balancing the electricity price and be a part of a new system where industry and power generation companies can interact more than today.
Mikael and Lars, because Ove, you are part of the other ones.
I have a problem in seeing who would do all those investments if the electricity price curve is constantly going down, closer and closer to zero. So where is the money coming from to all those capacity investments? I think there will be a turning point quite soon, either in the way that someone steps up and say, yes, we are as a large collective group willing to pay the subsidies for having so much additional capacity brought to the electricity market, or someone is or then something is turning around, so the price goes to a level which supports investments without subsidies.
I'm not really an electricity expert, but I do know that chemical plants need a very high service factor to operate. And we're talking about now producing methanol or hydro, anything, when the electricity is cheap. That means at peak situations. And I think there will be problems getting a profitability on such units if we invest a lot in a service factor that is far beyond the full year.
So what you're actually saying is that it's hard for you to be part of this new flexible electricity system.
I would, of course, very much like if there were components coming out of a system, cheap methanol or cheap hydrogen, that I could use, but I doubt that the electricity price will be stable and low over so long time that it actually justifies these kind of investments in large scale. I hope I'm wrong, but it's just a concern I have, having seen a lot of calculations on chemical plants.
Mikael, comment on that as well? No?
No, I can just comment on that and what Ove said. Our hopes for the digitalization promises that can be achieved in the future, when you can have market players that can sort of gather consumers to be a sort of a balancing power in the system. And given that consumers sort of give over control of certain parts of their system to an actor, can sort of create additional value chains, so additional models for businesses in the future that can tackle the problem with various inputs and outputs.
Just a question, we'll let Ove answer as well. What is your hope on the industrial sector when it comes to this flexible electricity generation system?
I think already now we have quite good possibilities to interact with the industry, to operate industrial, say, microgrids or something like that, as a part of, as a kind of one customer and so on. So I think from a technical perspective, I think we're quite far ahead. But then, of course, we need to get all the policies in place. What is a grid operator allowed to do and so on. So I think that will take more time than the technical development.
Yeah. All right. Henrik, you got a question?
Yeah, yes, I have a question about this digitalization on the operating system, because as you say, you have the same thing with the cars. You have the driver, and then you go autonomic car. At some point there, you have a situation where you get the operators inactive. So how much can you actually save on the operators in relation to what you actually have today on a safe operation?
It's difficult to say, but the more we look into it, the more convinced we are that it's definitely worth all the investments we make into improving the control systems. We are working together with WASP. We are a part of WASP in this context, and our focus is to really start from the process systems we have today, the DCSs in the mills, and make them more intelligent, to have better utilization of all the information that they already collect, to predict what is going to happen in the third step from this unit operation, where I have a change now due to some process changes in process conditions. This impact, what will that be 3 unit operations down the road and so forth. So maybe internal heat consumption in the range of 5 to 10% savings potential due to this. Smaller definitely on the electricity side. Yeah, definitely. And also we have been running projects in a couple of mills with gamification to keep the operators more alert. So gamification of the production process to help to push them to seek the rewards all the time when they improve the process controls.
Okay, we shall close this session by actually asking Simon, what do you bring from this session so you change and get even better?
What I bring from the session, I'll reverse that and say I really would like to come back to this and put the last question to our friends on the other side of the room here. Could you open the session, I thought, by these targets in terms of 2030 and significant reductions of energy intensity. But if we just look at, this is the Stenungsund example, but we've done similar work with the Preem complex and the numbers are not significantly different. This is big stuff to achieve 54 megawatts, which is maybe 10% of the total fuel firing capacity in Stenungsund. And that's not very much compared to the targets you were. In fact, it's essentially not enough. And yet, as we know, to do something, just the first step of this, which would be about a third in terms of potential savings, it's difficult. So somehow we get into this disconnect between what's really needed. It's complicated. It needs a lot of careful planning and commitment and so on. But we have these aggressive targets by 2030. And I somehow see a disconnect there. Do you feel that disconnect out in industry, and how do you react to it? So you see these brilliant ideas that engineers can come up with, but on the other hand, you have a lot of other things to take into account, and you have these political targets which need to be met in some way or another. How do you make that equation fit together?
I have a question back to you. How much have you been advising the politicians setting those targets?
Well, they paid for our work, so hopefully they read our reports.
Well, I'm sort of part of this example, so I know it quite well, and I see it that you have presented a big cake on the table, and it's up to us if we want to go and get it.
Yeah, actually, I think it's kind of not easy to solve on this floor.
No, I don't think we'll solve that within the next 10 seconds.
But I can say when I was a PhD student like 15 years ago, we had the same question, actually.
Okay, yes.
So I hope something will happen in the next 15 years. Thank you so much.